first of all, what will you do? Make the top, instead of a disk, make it a part of a sphere. Is that first of all understood? Understood. What are we doing, sir? We are trying to find out the solid angle. But sir, what is alpha then? Alpha is the linear angle at the apex. Up till now, whatever you have been calling alpha used to be the angle at the apex angle, and that too semi-angle. Half is alpha. Can you see that? Half angle is alpha. So what's the TFT? To find what? To find what is the solid angle subtended by a cone whose semi-vertical angle is alpha. I'll repeat. We are here to find out solid angle for a cone whose semi-vertical angle, linear angle is alpha. Is the problem statement clear? Correct, sir. L is, let's say, the slant height. Let's assume it. Step 1, create symmetry. How do I do that? Dome it up. What? Yep, dome it up. Watch. I domed it. What's that dome? Dome is a part of a sphere. Let me draw a horizontal diagram for you to show you what I'm trying to tell you. So this is what I'm trying to tell you. Okay, let me draw even bigger, huh? Even bigger. Why not? My pleasure. And then, like the way we always do, I'll have a master diagram using graphics for you. Watch. I have deliberately made the cone horizontal for you for better visualization, not better actually, to cover all bases. So this angle is alpha, guys. Okay, I'm about to shade the area, and this is L. Yes, sir, this is L. Sure, na? Sure. Now I'll tell you on paper what I'm trying to do here. What I'm saying is that you have to find out this complete area. This area. And the solid angle will be equal to what? This area, whatever you find out, upon L square. 20 seconds for you to at least absorb what is about to happen. Then we go ahead. Sure? Are you clear in what's about to happen? 100% sure? 100% sure, sir. Let's go ahead. Instead of the symbol L, I use a symbol R now because that is the acting radius. Correct. So, area. What we do is we take a very small elemental strip. Okay. At an angle theta. Okay. Of the angular thickness d theta. Okay. So what is the metric thickness? RD theta. Correct. How do you find the radius of a strip? How do you find the radius of this strip? By simple trigonometry. The complete radius is R, II. This is a right angle triangle, II. This is R, this angle is theta. Height is R cos theta, that is R sin theta. Fair enough. Got it. Is R sin theta radius of elemental ring? But sir, what is elemental ring? Do you remember the derivation of hemisphere? Isn't it a collection of coaxial rings one over the other? Why are you looking only a part of it? Because you're looking at the frontal view, elevation. Acha, okay, got it. Otherwise, remember in Central Mass I said ever youth facial peel mask, how you beautifully take the peel of the orange. So a sphere is made up of what? Peels, right? Rings, what do they have in common? They all have the same axis, coaxial. But what's changing? The radii are changing. In this case, it's r sin theta, correct? But how do you find it out? Circumference into thickness. Integral circumference into thickness. Do you get that part? And here is a top view for you. Any questions so far? No, not a problem. So S is equal to what? Integral 2 pi r sin theta II multiplied by RD theta II. Limits please. Let's be clever. Limits. I know. Minus alpha to alpha. No, 0 to alpha. Because the left, it's a whole ring. When your angle goes from 0 to alpha, the left side is automatically getting covered. Oh, yep. What happens? Sir, 2 pi r square comes out. Very good. What's inside? Sir, inside is integral sine theta d theta. Very good. Limits 0 to alpha, sir. Very good. So 2 pi r square remains as it is. Very good. Integration of sine theta d theta with respect to theta. Minus cos theta. Very good. 0 to alpha. Correct. What is it? 2 pi r square. Can you absorb the minus and switch the limits? So if you absorb the minus, it becomes alpha to 0. What is cos 0? Last time I checked, it's 1. And put theta as alpha. 2 pi r square 1 minus cos alpha. Is it? Yep. And what is the solid angle? It's supposed to be equal to s upon r square. Now from 2 pi r square 1 minus cos alpha upon r square, take the r square off. 2 pi 1 minus cos alpha I am getting. How about that?